Welcome, students, to solving exponential equations with equal bases, which is on page 4 of your notes. So when you have equations like this one, when both sides of your equation have the same base, you can solve the equation by setting the exponents equal. And by same base, we mean the base of the exponent. So like the 2 in these cases, or the 5 or the 10. It's the number that gets the exponent. That's the base. So I have this cheat sheet of powers here for you. In case you don't know your powers by memory, then there's an easy kind of sheet up here to look at for some of the practice problems. So I actually want to start with example 4 today instead of this one, although we will get to this one. I wanted to start with example 4 because you can see that both sides of the equation have 5 to a power. So 5 to the 3x power equals 5 to the x plus 8 power. So notice my bases are equal. So equal, I cannot spell today. Let me try that again. Equal bases. That's what we're looking for. So they're both 5 to a power on each side. So in that case, all you have to do is take your two exponents, so 3x and x plus 8, and set them equal. So basically, if I'm taking 5 to some power and it equals 5 to some other power, those powers better be the same number. Otherwise, we've broken reality. So now at this point, you just kind of do reverse Pemdas as you would usually do. So I've got an x on both sides, which means I need to eliminate one of them. I don't know what is with this camera today. Stay. And I'm going to choose to eliminate this x because then I'll have the x's here and then just an 8 on this side. So subtract x from both sides. So I have 2x equals 8. And then divide by 2. So I get x equals 4. And that was all there was to it. So that's if it's already kind of set up for you and the bases are equal. Now sometimes you'll have one like this example up here, where I have a 2 here and a 2 here. That's good. And on this side I have a 64. Now it looks pretty hopeless. It looks like I'm not going to be able to use that method at all. But in reality, got this cheat sheet right here that tells me that 2 to the 6th power is 64. So what we're going to be doing is taking that information and replacing 64 with 2 to the 6th power. So we'll get to that in a second. The first thing I want to do is simplify each side if necessary. So notice on this side, compared to this problem down here where it was just 5 to a power and that was it, here I have 2 to a power times 2 to a power. So I'm going to need to simplify that. Now, when I multiply two numbers together, then I need to add their exponents. And that's a rule that we did in Unit 4. If you wanted to look back at that, or if you wanted to come ask about that, that's something we did in Unit 4. So I need to add the exponents. So this is going to give me 2 to the 3x plus x is 4x equals 64 to the x minus 1. So all I did was combine these two to make 2 to the 4x. So yay, I simplified, woo! Next, write both sides with the same base. So this is where I'm going to take 2 to the 6th, which equals 64, and replace 64 with that. So I'm going to go ahead and write this side, 2 to the 4x equals. Then I'm going to take 64 and write 2 to the 6th, because I know 2 to the 6th power is 64. And then this exponent that was already there, I'm just going to multiply by the 6. So when you take a power to a power, you multiply the powers, and that's what we're doing here. So this side, I simplified it. I just added the exponents together because I'm multiplying the powers. And this side, I'm replacing 64 with 2 to the 6th, and then just multiplying the other exponent that was already there. Okay, so now I have 2 to the power of 4x equals, and then 2 to the 6 times x is 6x, And 6 times negative 1 is negative 6. So I have 2 to the 4x equals 2 to the 6x minus 6. So now this problem looks like this problem. I just have something to a power equals that same thing to a power. So now I'm going to go ahead and set the exponents equal just like I did here, and it's going to pretty much be like this problem now. So I'm going to start with 4x equals 6x minus 6. I got an extra x on both sides. Of course, I have to get rid of one, so I'm going to get rid of this one because that'll leave me with just a negative 6 here and all the x's on that side. So I have negative 2x equals negative 6, and divide by negative 2, which gives me x equals 3. All right, so let's try this next one. I have 10 to the power of 3x minus 6 equals 1. Now remember, I want it to be 10 to a power. Because if I have it 10 to some exponent, so let me not write that there. So if I can get 10 to some power equaling 1, then I can use this method and just set the exponents equal. So let's look up at our cheat sheet. Let's see if we can find 10 to some power equaling 1. Oh, look. So that's something to remember again from Unit 4, way back in December, I want to say. Any non-zero number to the power of 0 is going to be 1. So I'm going to replace 1 with 10 to the 0. So I have this right here that I'm going to be replacing. So I have 10 to the power of 3x minus 6 equals, well, instead of 1, I'm going to write 10 to the power of 0. Cool? So 1 is really 10 to the 0. So I'm going to make that substitution there. Then, now that I have my bases equal, then it's like this problem that I had over here, and I can just set the exponents equal. So 3x minus 6 equals 0. Then add 6 to both sides. Divide by 3. So x equals 2. Okay, so now I'm going to kind of try to lead you through this one step by step with the Edpuzzle questions. So think about, what is the first thing you're going to do? Okay, good. Hopefully you said that you want to try to get the bases the same. So if you look at your cheat sheet, I'll notice that 4 is 2 squared. So I'm going to try to use that right there. So I'm going to put 6x plus 2 equals, and then what am I going to replace 4 with? Cool, so hopefully you said 2 squared. And then don't forget that exponent that was there already. Don't forget it. Don't forget about it. It's still there. Okay, so then I have 2 to the power of 6x plus 2 equals, and then how would I simplify that? What would that look like? Awesome. Hopefully you said 2 to the power of 8x. Awesome. So now that my bases are equal, what is my next step? Remember, you got the steps up here for you. What would go next? Awesome. So hopefully you said you're going to set the exponents equal since the bases are now the same. So I have 6x plus 2 equals 8x. And then I'm going to subtract 6x. And then finally divide by 2. And I get x equals 1.